Hello and welcome to all my young friends who are studying in intermediate and they are watching this video. Welcome to this Calculus Made Easy series. In our earlier videos, we had discussed some topics which were very important before we start the actual topic, which is calculus. So today we are going to start our actual topic, which is called calculus, in this Calculus Made Easy series. So let us just have a recap of what we discussed about calculus in the introductory part. We said that calculus deals with study of continuous change. Whether it's a variation of speed with time, like this, one variable, which is speed, is varying with time. I have just plotted a graph. You just see the speed, it's varying, it's increasing. Then here it is, decreasing, it decreases to a value, again it increases, and then it decreases. So there is a change in this variable of speed with respect to the variable time. Or just take a common example. In a day-to-day life, our BP also varies with time. Whether take the time on a daily basis or with respect to age. So you find changes here, and changes are found in lots and lots and lots of places. Whether it is the problem of physics, chemistry, or even economics, anywhere you will find changes. So it is imperative that these changes need to be studied. Now we said that change can be studied by establishing relationship between different variables. For example, in the earlier slide, I said that there is a variation in speed with time. So if we are able to establish a relationship between speed time, we can study this change. A particular relationship where for each independent variable there is only one dependent variable, that is called a function. We have already discussed in our previous videos. If you have not seen them, please do see them. So particular kind of relationship is called a function, and calculus is mainly devoted to the study of function and limits, and limits we are going to discuss shortly. Now there are certain checks for a function. Before we start the topic of limits, let me tell you there are checks for a function. What do we mean by check? Let me give a very interesting example from our day-to-day life. Suppose you are going to gift a shirt to your friend or anybody. So after purchasing the shirt, after you get the shirt for the required price and the required color, you do certain checks, whether stitching is okay, buttons are okay, color is not faded, shirt is not torn at any place. So these are all the defects which you check before giving the gift to anybody. These are certain shortcomings which are required to be checked. Similarly, there are certain checks for a function. Now don't compare this example mathematically. This is just an interesting example so that you remember this. That's it. So before we give a gift of this shirt to anybody, we need to check the defects. Similarly, before we employ the function in our study, we need to do certain checks there. What are the checks? I have already told you, please don't connect it mathematically. This is just example is just for the for the sake of making it more interesting. That's it. First check is limit, whether the limit exists at a point. The second check is continuity, whether the function is continuous or not. The third check is differentiability, whether the function is differentiable or not. Today we are going to deal with a limit, and in the subsequent videos we'll deal with continuity and differentiability in detail. So limits is going to be discussed in detail in good number of videos because it's a very vast subject, and it's prerequisite for understanding calculus. So please give proper attention and see all the videos in sequence. I've already put it in playlist in sequence, but don't uh, omit any video. You have to see it in sequence so that you get a fair idea and none of the concept is missed. Now, what is a limit? This is the definition that limit is a fundamental concept in the field of calculus where we analyze the behavior of the function in the neighborhood of a particular point. At a particular point, when we analyze the behavior of function in its neighborhood, so limit is that fundamental concept where we do this. Now, limit is prerequisite for understanding continuity and differentiability. I already told you that this is, prerequisite not only for understanding continuity and differentiability, but for the whole calculus, because this is the base. Limit is always determined for a function. Hope you are clear with this. So let's proceed. Let's, take example of functions. We have fx is equal to 2x plus 8, or we also write y is equal to 2x plus 8, or y is equal to sin x, or y is equal to x square plus 1. That's the same thing. Now, these are some examples of functions. There can be many number of functions. Just to give you some example, I have put one or two, functions. A very simple kind of function. Normally, in your previous classes, you must have read something about functions, and you must have, done some questions of finding value at a particular point. For example, let me, explain you. Fx is equal to 2x plus 8. Now, what is f1 is equal to 2 into 1 plus 8, which is equal to 10. You can find value at any value of a function at any value of x. Similarly, in the second function, fx is equal to sin x, so f pi by 4 is equal to sin pi by 4 is equal to 1 upon under root 2. Third, fx is equal to x square plus 1. So f3 is equal to 3 square plus 1 is equal to 9 plus 1, which equals to 10. Here what we have done, we have just put a value of x and we got the value of the function for that value of x. So in all these above cases, we can find the value of function for different values of x. But this is not possible every time. Why? If we get some indeterminate forms on putting the value of x, suppose the function assumes indeterminate form. Now, what are indeterminate form? 0 upon 0 means numerator as well as denominator becomes 0. Infinity upon infinity. Infinity minus infinity. 0 into infinity. 0 raised to the power 0. 1 raised to the power infinity. And 0 raised to the power infinity. If we get indeterminate forms like this, then there is a problem. then we cannot find value. Value cannot be found because these are indeterminate form, not defined. So that time we find the limit. Otherwise, we just find the value. That's the limit. But if we get these forms, this indeterminate form, then only we find the limit. Now, what do we do when we find the limit? For finding the limit, we analyze behavior of function in the neighborhood of that particular point. For example, at a particular value of x, say a, we get an indeterminate form, any of these 7 forms. Then we analyze the behavior of the function in the neighborhood of that point, that is a. So how do we do that? And what do we mean by that? So let me explain you with some interesting example before that. This is a neighborhood. Houses are adjacent to each other. Now suppose we have to give feedback about a particular person living in this house. This house. So what do we do? Suppose you are asked that you need to give a feedback about a particular person who is living in this house. If you are told to do this, you are interested with this responsibility, what will you do? You will go to that house, meet that person, talk to that person, and then give the feedback. But if the house is locked and nobody knows where is this person, whether he is going to come today, after 10 days, after 1 month, or after a year, nobody has any clue about it, so it's not certain that he is going to come. But feedback is very essential on that very particular day. You need to give feedback, and you are told that today he is not going to come. There is no way that you can meet him. Then what do you do? But feedback is essential that day. You have to give the feedback. Then you take the help of neighbors. What do? You just talk to the neighbors. You just go on this side, you just go to this house, talk about, inquire about this person, about his behavior, whatever traits you want. Then you move a bit closer to this, next door neighbor. I have only, depicted the 2 houses. There can be more number of houses. So here the feedback will be even more genuine because this is just in the vicinity of this house, particular house. You take the feedback. Then you also go on the left hand side. You go to this house and you move again towards this house closer. So the feedback which this house is going to give you will be more correct because he is the next door neighbor. Now you collect all the feedback on right hand side and you collect all the feedback on left hand side. Now this is only just to explain you in an interesting manner. So don't go much into the details of this explanation or this example. Don't connect it mathematically, right? This is just to explain. Now, if you get some positive feedback from right and you get positive feedback from left also, so you take this feedback. If both the feedback matches, so that means there is some feedback exists about the particular person. Or you get a negative feedback on lefts and you get again a negative on right. Then also in that case, whatever feedback you are getting on the right, the same you are getting on the left. So that means you take that as a feedback. But if you get a positive feedback on right and some negative feedback on left, or you get positive feedback on left and negative feedback on right, that means there is a confusion. Feedback does not exist. Feedback does not exist. No proper feedback exists for a person. Right? So this is just an example to tell you what do we do in case of a function. Now, coming to mathematics, we are telling that if a function assumes indeterminate form, that means you can't find the value. House is locked. Then you go to neighborhood, and then you go on the right and see, and then you go on the left and see. So now just, let's see what we do for a function. Now, suppose you have to find limit of a particular function like this. Fx is equal to x square minus 1 upon x minus 1. Now you can easily see that f1 is equal to 1 square minus 1 upon 1 minus 1, which is equal to 0 upon 0. So this is the indeterminate form. That means the house is locked. So what do you do? At 1, you cannot find the value of function. Then you find the limit at x is equal to 1. Right? So what do we do? We will find the limit. Now I'll just show you one or two methods by which we can find the limit. Let's make a table. Now in this row we have values of x, and here we have values of fx, means this whole function. Now you know that at x is equal to 1, this is undefined, indeterminate. Now you move right to the function, that is somewhat higher than 1. Say take 1.1. Now you just see what is the value which you are getting at 1.1. So 1.1 whole square minus 1 upon 1.1 minus 1, which is equal to, you can write 1 as 1 square, 1.1 minus 1, 1.1 plus 1 upon 1.1 minus 1. Right? So this will get cancelled. This will become 1.1 plus 1, 2.1. Even if you don't cancel and multiply, you will get the same 2.1. Right? So you got the value 2.1. Now come a bit closer, 1.01. Similarly, you will get the value 1.01 whole square minus 1 square upon 1.01 minus 1. So similar to the procedure we adopted, this will come 1.01 plus 1, which is equal to 2.01. Again, come a bit more closer. Now if you just put the value of 1.001, you will see that you get the value 2.001. I have only depicted 3 cases. There can be many cases, right? So now we move towards left. What is left? Something less than 1, which is 0.9. Just put the value of x as 0.9, 0.9 square minus 1 upon 0.9 minus 1, which comes to 0.9 minus 1, 0.9 plus 1 upon 0.9 minus 1, which will be 1.9. So this is the value which you get when you move to the left. Now again from left you try to come closer to 1, put the value as 0.99, you will get the value of function as 1.99. Come a bit more closer, 0.999, you will get the value as 1.999. Now we can see that as we move from right towards 1, that is x approaches 1 from the right, the value of the function approaches 2, because here it was 2.1, here it is 2.01, it is 2.001. So value is approaching 2. Or if you see from the left, when x starts approaching 1, same, the function approaches to 1.9, 1.99, 1.999. So either from left or from right, the function approaches to. Hence, we say that, we write like that, limit x tending to 1, fx is equal to 2. That means as x tends to 1, it has not become 1. It is not equal to 1, because if x is equal to 1, we already have said that function is undefined. As x tends to 1, fx is equal to 2, and we treat it like that, limit x tending to 1, fx is equal to 2. Just note the difference. For value of a function, we write x is equal to a. Say in this case, if we are able to find the value at 1, we write x is equal to 1. But since we are not able to find the value of the function at a particular point, we will find the limit. So we will write not x is equal to a, but x tending to a, which is shown like this. This means x tending to 1. X tending to 1. So this is one way of finding the limit. Now let's understand it graphically. Now you can see here I have written fx is equal to x square minus 1 upon x minus 1. X is not equal to 1. So this function is valid till x is not equal to 1. Otherwise at 1 it assumes indeterminate form. Earlier I had not written x is not equal to 1, but now since I have explained you the idea of indeterminate form, so I have written it here. So now if you just see this function, this is x square minus 1, you can write 1 square upon x minus 1. So it comes to x minus 1 upon into x plus 1 upon x minus 1. So this will get cancelled. But this can only be cancelled if it has some value, if x minus 1 has some value. For example, at x is equal to 1, this is 0 and this is 0. You cannot cancel 0 if you have 0 in the numerator and denominator. Now, you can only cancel when x is not equal to 1. So, that means y is equal to x plus 1. So, this function can assume this form only when x is not equal to 1. Now, just trace this line. Minus x plus y is equal to 1. That means x upon minus 1 plus y upon 1 is equal to 1. Now we'll try to trace this function. Right. So this will have an intercept of minus 1 on x-axis and 1 on y-axis. That means like this. But this will not have, this will be undefined at 1. At x is equal to 1, you will have a gap like this, and then this line will, you know, proceed after that. Only at x is equal to 1, you will have a gap. You don't know because function is undefined. Now what we do? We again go towards right side of 1, say this, and then we'll go on left, say this point.